Cosmic origins of life. Molecules from space reveal shocking secrets. Could the building blocks of life have originated in outer space? That's the intriguing possibility raised by a recent astronomical discovery. Astronomers using the Atacama Large Millimeter Submillimeter Array, ALMA, have detected signs of complex organic molecules, potential precursors to sugars and amino acids, in a planet-forming disk around a young star. This suggests that the chemical evolution necessary for life may begin even before planets are fully formed. But here's where it gets controversial. Building blocks of life, complex organic molecules found in planet-forming disk. Imagine a universe where the building blocks of life are scattered throughout, waiting to be assembled into something truly remarkable. This idea may seem like the stuff of science fiction, but it's becoming increasingly clear that the raw materials for life are more widespread than we ever thought possible. Astronomers have made a groundbreaking discovery, finding 17 different complex organic molecules around a protostar called V883 Orionis. But here's where it gets really interesting. They've also detected the first tentative signs of ethylene glycol and glycolinitrile, which are precursors to crucial building blocks of life, such as amino acids and nucleobases. These molecules are the stepping stones to life, and their presence in a planet-forming disk is a tantalizing hint that the universe may be capable of creating the conditions for life to emerge. But what does this really mean? Does it imply that life is inevitable, or that the universe is somehow primed for the emergence of complex organisms? The answer, of course, is far from simple. The discovery of these complex organic molecules, or COMs, is not a surprise in and of itself. We found them in all sorts of environments, from giant molecular clouds to the tails of comets. However, the process of star formation is a highly energetic one, and it was unclear whether these molecules could survive the intense conditions surrounding a protostar. The team, led by Abu Bakr Fadul from the Max Planck Institute for Astronomy, used the Atacama Large Millimeter Array, ALMA, to study V883 Orionis and detect the intriguing molecules. And this is the part most people miss. The fact that these molecules can exist in such an environment and survive the star formation process is a strong hint that they could eventually incorporate into planets and create a favorable environment for life to emerge. As Fadul told IFL Science, finding these molecules in such an environment is really exciting because this is the last stage after the star is formed, but before the planet is forming. But here's the controversy. If these molecules can form and survive in the harsh environment of a protostar, does that mean that life is more likely to emerge elsewhere in the universe? Or are we just seeing the remnants of a complex chemical process that has no bearing on the emergence of life? The answer to this question is still unclear, and it's one that has sparked intense debate among scientists. Some argue that the presence of these molecules is a clear indication that the universe is capable of creating the conditions for life to emerge. Others claim that it's just a coincidence and that the emergence of life is still a highly improbable event. So what do you think? Do you believe that the discovery of these complex organic molecules is a sign that life is more likely to exist elsewhere in the universe? Or do you think it's just a fascinating example of the complex chemistry that occurs in space? Let us know in the comments. The results of this study are published in 3 papers in the Astrophysical Journal letters, the Astronomical Journal, and the Astrophysical Journal. As we continue to explore the universe and search for signs of life, discoveries like this one remind us that the possibility of life existing elsewhere is very real, and that the universe is full of mysteries waiting to be uncovered. Cosmic origins of life? Complex chart molecules found in stars' disk? The universe may be whispering the secrets of life's origins through the cosmic song of star-forming regions. Imagine a celestial nursery where the building blocks of life are crafted from the most unexpected of places. It's a story that's as awe-inspiring as it is controversial. But here's where it gets controversial. The very ingredients for life might be more widespread than we ever thought possible. Think of these organic molecules as the cosmic Legos that can form the foundation of planets, moons, and potentially life. What's fascinating is that these molecules are more abundant and complex in fully evolved planetary systems, compared to the star-forming regions they originate from. This suggests that the seeds of life are assembled in space and are widespread, like a cosmic blueprint for life itself. Now it appears the opposite is true, says Camber Schwartz, the co-author on the study. Our results suggest that protoplanetary disks inherit complex molecules from earlier stages, and the formation of complex molecules can continue during the protoplanetary disk stage. This challenges the prevailing notion that these molecules are destroyed in the birth of a star. The transition from a cold protostar to a young star surrounded by a disk of dust and gas is a violent process. However, this period might not be long enough for COMs to form in detectable amounts. Instead, the conditions that define biological processes may be widespread, present in various stages of star and planet formation. Astronomers have found the simplest organic molecules, such as methanol, in the dense regions of dust and gas that precede star formation. Under the right conditions, these regions may even contain complex compounds like ethylene glycol. We recently found that ethylene glycol could be formed by UV irradiation of ethanolamine, a molecule that was recently discovered in space, adds Tushar Suasaria, another co-author. This finding supports the idea that ethylene glycol could form in various environments, from interstellar space to the later stages of molecular evolution. The discovery of complex organic molecules in V883 Orionis is a tantalizing glimpse into the cosmic origins of life. But who knows what else we might discover? Perhaps the universe is full of secrets waiting to be uncovered. What do you think? Are we alone in the universe? Or is life more widespread than we ever imagined?